All right, so this is going to be a tri-state bus. We're going to have two source registers. We're going to have two destination registers and a bus mux to control it all. So for this, we just need two components. One is a 4-bit register, and the other is the bus mux. As you can see, I have only the project set up, and we're going to get started. The first thing I'm going to do is I'm going to create a block diagram as my top level domain. And all I'm going to do is just put a pin in. We're going to save this as the tri-state bus. Now, we're going to go ahead and do the VHDL. So, basic infrastructure right there. And the way I'm going to do this, I'm going to do a nested if loop. And the way I'm going to do this is I'm going to look at the enable, and if the enable is high, then I'm going to look for a clock edge. Rather than look for a clock edge and then see if the enable is high. Now, it might need to be a high, it might need to be a low. It just depends on the switching mechanism you're using. Remember, a lot of buttons they go into the FPGA as a high naturally, so you'll want to have those as lows. And then this is and I'm using the rising edge function. You don't need to do this. If you feel more comfortable using the defining outer edge, that's fine. And now, when I have a rising clock edge and the enable is high, I want my in to be my out. And that's all that I need to do for that one. Now, the one thing about this is that because it's using, it's going to be using a common bus, we want to put it into a high impedance state when it's actually not being used. Because in this situation, 0000 is an actual valid data source. So we're going to put it as a high impedance. And to do that, it's when anything else is going on, I'm going to set it as Z's. Oop. And we're going to end the if. And the process. And in the architecture. Now, I did not put in my actual what we're processing, and it is just these right here. So we look it over. Nothing stands out immediately as a problem. So we're going to go ahead and save this. And it goes through fine. Now what I'm going to do is I'm going to just test this item right off the bat. You can build it all together and then go through the testing. I find that testing at the smaller level works better because I'm not confusing myself with everything that's going on. get an A. When it's low, it's get a Z. So I'm going to call that working. So we'll go on to the multiplexer. So this is a little bit different. For this one, what we're doing is we're bringing in the two different registers, and then we're going to output it onto a single output, which is the mux by definition. The other thing that we're going to do is we're going to use a 2-bit select, and what that's going to do is that the select for the bus 1 for the reference 1 is high and the other one is low, then I want it to transmit number 1, and vice versa. If 2 is high and 1 is low, I want it to transmit 2, else I want it to be a high impedance. So for this I need some selects, and they're just standard bits. I'm going to need those inputs, and I'm going to call these Ds. Now these are inputs as well. Try to keep my formatting right. And it's the formatting I'm used to using. Quartus does not care. And then I need to have my out. And this is also, since we're bringing the 4-bit arrays through, it needs to be a 4-bit array. All right. Now to the architecture. Now, before I get too crazy, I actually need to end the entity. Again, don't need a signal. And go ahead and hit this before I forget. Once again, this is what I'm processing. It's not every input that I'm processing, it's just the things that are controlling the system, or controlling what I'm going to actually be using. So for this, I'm just going to do I could make it fancy and make a signal and concatenate these two together, but Oops. And this is going to be my one where I want the select 1 then. And this is going to be select out. It's going to be assigned select 1D. I'm going to cheat a little bit. If I can actually hit the right keys. That's 2. That's 0. That's 1. And easy copy. That's my 2 states, but I still have 2 other states that it can be, for a total of 4 states for the entire thing. So those I want to be a high impedance, and I'm going to use the same thing as I did earlier. So not above to copy my own code. Yeah. And then process and all the goodies. All right, that should have that done. So just going to save this right quick as I start the compile process. And we got a problem. All right. Expecting identifier. What am I doing wrong? So this is an important thing to note. Bus on its own is an actual reserved word. And so need to make sure you're not using reserved words. In this case, I just left out my underscore, and I probably actually want to make sure that I'm using the same capitals throughout. All right. Now, I forgot to put the and in. Oops. Silly me. All right. Used but not declared. Oh. Problem when copying code is you don't use the same variables. And that looks like it did it. So once again, I'm going to test this out here in a minute. Just get it saved up as the top level entity. And let's go ahead and run a vector waveform file. All right, so for this, gonna go ahead and set these as those hexadecimals. You're supposed to group. And for testing purpose, I'm just going to walk through the selects. So arbitrarily, I'm assigning values, hexadecimal. And we're we can't use a count. If I use just the clock signal here, what you'll see, let me take it out to 100, is it goes 0011 0011. That's because it's toggling both at the same time. This is why we use the count, is it actually counts up. All right. So go ahead and run this as the mux. And you can see here, Z6A, ZZ, everything where I want. Looks like it's going to work. So for this, what we're going to do now is we're going to go back and set that as the top level entity. The bus mux, I want to create a symbol and file. I'm going to create a symbol and file of that. And let's go ahead and add our entity, our stuff. I'm going to add my output pins right quick. I only have 2. And the rest of these are going to be input pins. All right, so drop this down a little bit. Yeah, I cheated a little bit. So naming convention. So this is going to be my clock. This is going to be the, what did I call this? Source 1 enable, and this is D1 in. This needs to be a bus. This could be source 2 enable, and then D2 in as a bus. All right, so select 1 OE, select 2 OE, yeah, like those. I'm going to put in enable. Need to check something. Huh. All right. All right, so those pins are in. Now, whoops. Gotta remember these are array pins. All right. Yeah, I'm doing this the cheesy way. All right, so one couple more that I can cheese away. All right, and get the naming on this. This is dust 1 enable, dust 2 enable. All right, so for this, I'm just going to hello. Gotta be careful about that. Whoops. Oh. I'm just gonna move this line over so it's a little bit easier to see. All right, so that's all the clean connects that I can do. What I'm gonna do is I'm gonna take these, I'm gonna move them out a little bit more. And what I'm gonna do is I'm gonna actually label this line clock. And then just gonna do that. On. Let's see. This, I'm going to do the same thing, but because it's a bus, I need to make sure it says bus. And I'm just going to move the labeling around a little bit so that it's actually viewable. All right. That should be everything hooked up. So we'll give this a test. And it looks like it's going to work. So once this gets done, I'm going to do one more test with the vector waveform file. It's the node finder list, select all. Okay, okay. Now this is where it gets a little more confusing because I have all these ins and all these outs. So what I'm going to do is I'm going to organize this, and I'm going to organize it in a logical arrangement. So the first thing I'm going to do is I'm going to actually change the value, the radix on these to hexadecimal. All right, so I have destination in. All right, so all these destinations need to move to the bottom because they come last in everything. So I could leave that there. I could do, let's see, I like those two right there. Select OE. So these are the enabled. So let's go ahead and clock this bad boy. Yeah, I like that. Let's send it to 20. And let's arbitrarily assign some values here. Let's see. Now, what I want to do is I want to see if I put in the right combination, if they go to the right destination. So what I want to do is I want to put my in from my D1, which is my source 1, and put it out on destination 2. So to do that, I'm needing to hide this, I need to hide this, and I need to hide this. But I need to hide them at certain times. So what I'm going to do is I'm going to grab this little bit of real estate, and I'm just going to select hide. So that enables the source registry 1. And then this is going to tell the mux that I want it high as well. And then this is going to tell the destination 2 that it's going to receive this. So that should put A out on destination 2. Now, what else I'm going to do is I'm going to test some of the timing stuff. So I've got this. This is source 2. And I'm going to send it high. And I'm going to put it on destination 1. So source 2. I'm going to do that. No, let's do this. Let's do a little more than that. I'm going to do that. So you see there's a little overlap of a couple of cycles. And then source 1, I'm going to grab that part and make it high. And so that's going to test not only is it going to show that I can go from the other way around, it's also going to show when things turn on and off for the destination. And so we're going to save this as complete. And so what you can see here is this right here, which makes sense. This one was on the falling clock edge, so it didn't turn on to the rising clock edge. And when the stuff went negative, it went fine. And so when you look at this, you have, it doesn't turn on, it turns on the next clock cycle. So that is a timing. And it stays on until then. So that should work. And so that is the coding for the Tristate mux. And I'm not going to go through the wiring on it, because that's basically wiring. So I hope you get something out of this.